That is real-time hand tracking, running on a Raspberry Pi 4. No GPU, no cloud, just a Pi, a USB webcam, and the right setup. I'm going to show you exactly how to get this running. And more importantly, why it probably didn't work the last time you tried. Here's the honest truth. MediaPipe works on a Raspberry Pi, but there are 3 things that silently kill it, and most tutorials just don't mention them. First, NumPy2.x. The moment it gets installed, MediaPipe throws a runtime error about a compiled API mismatch. It just crashes. Second, OpenCV's default camera backend queues up stale frames. So even if it runs, you're processing what happened a second ago. Third, the default model complexity setting is way too heavy for the Pi CPU. It destroys your FPS before you even start. 3 problems. I've fixed all 3. Let me show you. This is the repo. Link is in the description. 5 files, nothing extra. Hand_tracking.py, the main script. Every optimization is already in there. Requirements.txt, exact pin versions, the ones that actually work on ARM. Record_demo_gif.py, bonus script if you want to record your own demo GIF directly on the Pi, hands only on a black canvas, privacy safe. And demo.gif, that's what you just saw at the start. I've written a full README that walks through every step from scratch. Let me go through it with you right now. Step 1, update your Pi OS. I know it feels like a waste of time, but a lot of random install failures on Pi come from an outdated system. Just run it, let it finish. Step 2, install system packages. This gets you the Python virtual environment tools, OpenCV system libraries, the V4L2 camera utilities, and FFmpeg. All of these get used later. Step 3, verify your webcam. Plug it into the USB 3.0 port and run lsusp. Then check if you can see /dev/video 0. If you don't see it, try a different port or just reboot. Sometimes that's all it takes. Steps 4 and 5. Create your project folder in a virtual environment. Please use a venv. It takes 10 seconds and means if something breaks, you just delete it and start over. Activate it before you do anything else. Your terminal should show MediaPipe PNV at the start of the line. Step 6. Upgrade pip, setup tools, and will first. This is one of the most common silent failures on Pi. Old pip fails to resolve ARM wheels properly. Just upgrade it before installing anything. Step 7. This is the critical one. Install in this exact order. NumPy first, pinned to 1.26.4. Not 2.x, 1.26.4. Then OpenCV 4.8.1.78. Then MediaPipe, latest is fine. Pip will automatically pull the correct ARM64 wheel for your Python version. Pillow only if you want to use the GIF recorder. Step 8, verify. Run this one-liner. You should see OpenCV 4.8.1 and MediaPipe 0.10 something. If you see those 2 lines, you're good. Step 9, clone the repo. Step 10, activate your environment and run hand_tracking.py. Press Q to quit. Now let me show you what's actually inside the script, because understanding these settings means you can use them in any Pi computer vision project you build. The script is about 40 lines, but every single line is doing something specific. Let me walk through the key ones. Right at the top, CV2.setUseOptimized, true. The Pi 4 supports ARM Neon SIMD instructions. This tells OpenCV to actually use them. Cost you nothing. Inside the hand setup, model_complexity equals 0. MediaPipe ships 2 models. Complexity 1 is accurate, but heavy. Complexity 0 is the lightweight version, roughly 50% less inference time on ARM. It still tracks all 21 landmarks. This one setting alone makes the biggest difference. Camera setup, CV2.cap_V4L2. This forces OpenCV to use the native Linux camera API instead of the default path. Lower overhead, more direct access to the hardware. Right after, MJPEG 4cc. This tells your webcam to compress the frame in hardware before sending it over USB. It cuts USB bandwidth almost in half. One of the biggest FPS gains in the whole script. Then BUFFERSIZE equals 1. By default, OpenCV queues multiple frames. On a slow CPU, you end up always processing something old. BUFFERSIZE 1 means you always get the freshest frame. Resolution is set to 640 by 480. Lower resolution means less data per frame to process. Simple but effective. And just before calling hands.process, RGB_frame.flags.writable equals false. This skips an internal memory copy inside MediaPipe. Small gain, but it adds up over thousands of frames. All of these together, that's what takes you from 3 FPS to smooth real-time. And here's what it looks like. Dual hand tracking. 21 landmarks per hand. White dots on the joints, green lines for connections. FPS counter live in the top left. Running on a Pi 4 with a standard USB webcam. No cloud. No GPU. No Coral TPU. Just the Pi CPU, set up correctly. Quick errors section. If pip says no matching distribution found for MediaPipe, you're on 32-bit Pi OS. MediaPipe only has a wheel for 64-bit ARM. Run uname M in the terminal. You need to see Arch64. If it shows ARM 7L, you need to reflash with Raspberry Pi OS Bookworm 64-bit. If you're seeing a runtime error about API version mismatch, number py2.x got installed somehow. The fix is one line. Pip install numpy equals 1.26.4. Force reinstall. That's it. If you're getting a camera error or just a blank black window, your webcam is probably on /dev/video1 instead of video 0. Run ls/dev/video * to check. Then change video capture 0 to video capture 1 in the script. One character change. GitHub link is in the description. If this saved you the debugging time, drop a star on the repo. It helps other people find it when they're stuck on the same thing. Next video is finger counting. Building on exactly this setup, using the 21 landmark coordinates to count how many fingers are up. Subscribe so you catch it. See you there.